Hey, it's Mrs. Elward. I'm back. Difference of two perfect squares is my favorite kind of factoring because it is super easy. So to get the idea of difference of two perfect squares, it talks about multiplying conjugate pairs. Um, so I want to refer back to the last two questions on the first page of our double distribution notes. So we had x plus 4 times x minus 4. We double distributed, and then those middle two terms cancel out. So in essence, we did our x times x, which was x squared, and x times negative 4, which was negative 16. The same thing happened over here with our x plus 5 and our x minus 5, where after double distributing, those middle two terms canceled out. And in reality, all we had to do was our x times x being x squared, and 5 times negative 5 was negative 25. This is multiplying conjugates. So what we're going to do is we're going to practice that idea in our difference of two perfect squares notes real quick, and then go back and undo that process. So multiplying conjugate pairs, we have some terms a plus b times a minus b, and really all you have to do for your answer is a squared minus b squared. So here we go. So we have x plus 6 and x minus 6. So all we have to do is our x times x, which is x squared, and x or 6 times negative 6, which is negative 36. Right? Because x squared is x squared and 6 squared is 36, and we have the minus in the middle. It follows that pattern. All right. So then in part B, we're going to do 5x times 5x, which is 25x squared, and 2 times negative 2, which is negative 4. And lastly, notice how there's going to be two variables, and that's totally okay. It's just a puzzle. So 2x times 2x is 4x squared, minus 7y times 7y is 49y squared. So now we're going to undo that. We're going to go from this product back to the parentheses. So we should now be able to reverse this multiplication in order to rewrite the expressions that are the difference of perfect squares into products. So we're going to write each of the following first in the a squared minus b squared, and then as equivalent products of conjugate pairs. Well, they're already in that a squared minus b squared form. So here's how I like to do it. I set up my two parentheses. One of them is going to get a plus, one of them is going to get a minus, and then we just take the square roots of these terms. So we have x squared minus 81. So the square root of x squared is just x. And the square root of 81 is 9. And that's all you have to do. Easy. So let's keep going. We have 9x squared minus 4. Set up your two parentheses, 1 plus, 1 minus. The square root of 9x squared, well, the square root of 9 is 3, and the square root of x squared is x. So 3x goes in the front. And the square root of 4 is 2. Then we have 25 minus y squared. Set up your parentheses, plus minus. The order that they're in originally is the order they need to be in the parentheses. So the 25 comes first, and the square root of 25 is 5. So those 5s need to come first. The square root of y squared is just y, and that's last, so that's got to go last in the parentheses. All right, D. Two sets of parentheses. I'm going to make these a little bit bigger because there looks to be a little bit more stuff going on in this one. So we have 4x squared, square root both parts of that. So square root of 4 is 2, square root of x squared is x, so 2x in the beginning of our parentheses. And then we have 81y squared. Square root of 81 is 9. The square root of y squared is y, so 9y in the back of both parentheses. In E, we have 121x squared minus 1. The square root of 121x squared is 11x. And the square root of 1 is just 1. Okay. 1 minus x squared. Again, the square root of 1 is just 1. The square root of 4x squared is 2x. Let's get into some that have higher exponents. So when we have an exponent other than x squared, because we know x times x is x squared. So really what we got to do, so for instance, n to the fourth, well, what times itself is n to the fourth? Well, that would be n squared times n squared equals n to the fourth, all right? So all we're going to do is we're going to take our exponent and divide by 2 when we take our square roots, okay, to find what times itself gives us that exponent, okay? So we have n to the fourth minus 100. So we set up our parentheses again, plus minus. The square root of n to the fourth, we take 4, we divide by 2, that is n squared. And the square root of 100 is 10. So let's try that on a few more with these exponents other than 2. So we have x to the 10th minus 16. So the square root of x to the 10th, 10 divided by 2 is 5. So x to the 5th. And the square root of 16 is 4. All right, let's build it up a little bit. A couple different variables going on. So 9m squared, the square root is 3m. Put that in front. Square root of 81n to the 6th. Well, the square root of 81 is 9. N to the 6th, we divide by 2, and that gives us n to the 3rd. So 9n to the 3rd. And the last row. And then we're done with notes for today. We have 4x to the 8th minus 25y squared. Set up your parentheses, plus minus, and we take our square roots. So the square root of 4 is 2. X to the 8th, we divide by 2, so x to the 4th. So 2x to the 4th. And then square root of 25y squared is 5y. All right, now we have x to the 6th minus 100y to the 12th. So when we square root, we divide our exponents by 2, so that's x to the 3rd. Square root of 100 is 10, and then 12 divided by 2 is 6, so 10y to the 6th. And the last one looks pretty messy, but it's really not that bad. So square root of 36 is 6, but 20 divided by 2 is 10, so a to the 10th. So 6a to the 10th, just a puzzle. And the last one, square root of 49 is 7, and then we're going to do 30 divided by 2 is 15, so b 15. And that's it. All right. So your homework for difference of two perfect squares is in Schoology. It's a Schoology assessment-like thingy where you can do multiple choice. It'll tell you if the answers are right or wrong off the bat. And you can, if you get too many wrong, you're welcome to redo it as many times as you want till you get a perfect score if you want. Okay? Let me know if you have questions, if you need help on anything. And that's it. All right. Thanks. Feel free to log on to office hours with me or with Mr. Freilich and Mrs. Gibbs, and we'll help you out. Have a great day, guys. Bye.